Next we have our question number 6, which is sin A of 1 plus tan plus cos of 1 plus cot. First convert this in the form of sin A and cos to simplify the LHS value here. Let's go with our solution. The tan can be written as sin A by cos A, and the sin and cos remain same, and this cot can be written as cos A by sin A. Now we need to take the LCM of these two terms separately, and the LCM of this first term is cos and the LCM of the second term is sin. We'll get it as sin of cos A plus sin A by cos A into plus cos A of sin A plus cos A by sin A. If we observe here, sin A plus cos A is common in both the terms. Let's take it out as common. We'll take it out, sin A plus cos A. If we take these two terms outside, we'll get sin A by cos A, and the remaining second values are cos A by sin A. Now again let's simplify these terms which are inside this bracket, and the LCM of these two terms will be cos A into sin A. Leave this first two terms as it is. This remains the same. Next, here we'll be getting it as sin square A plus cos square A by cos A into sin A. And we know our identity, which is sin square A plus cos square A is equals to 1. Let's replace this numerator value with 1. So our remaining values will be sin A plus cos A into 1 by cos A into sin A. This we can write it as sin A plus cos A by cos A into sin A. So if we observe in numerator we have two terms. Let's separate those two terms and we'll write those two terms individually. We'll get sin A by cos into sin plus the second term, which is cos by cos into sin. So sin and sin, cos and cos gets cancelled. The remaining values are 1 by cos plus 1 by sin. And we know inverse of cos is nothing but secant, and inverse of sin is nothing but cosecant. This is our required RHS value. Next question we have is question number 17, which is 1 by 1 plus tan square plus 1 by 1 plus cot square. We need to prove this, or we have to simplify this to get our answer as 1, and we have our identities, that is 1 plus tan can be written as secant square A, right? And again this denominator, that is 1 plus cot square A, can be written as cosecant square A. Now let's replace these two denominators with our identities. We'll get as 1 by secant square A plus 1 by cosecant square A. And we know inverse of secant is nothing but cos square A, and inverse of cos is nothing but sin square. And we have our identity, that is sin square plus cos square is equals to 1. This is our required RHS value. Next, question number 18 is 1 by 1 plus sin plus 1 by 1 minus sin. So here just we need to take the LCM of these two terms, and the LCM is 1 plus sin into 1 minus sin. That means here we need to do cross multiplication. We'll get 1 minus sin A plus 1 plus sin A by the product of these two terms, that is 1 plus sin A and 1 minus sin A. And in numerator, minus sign plus sign gets cancelled. So here we have 1 plus 1 is 2. By here it is in the form of A plus B into A minus B. And we know A plus B into A minus B is A square minus B square. Now let's write our denominator in this form. We'll get as 1 minus sin square A. And from our identities we have 1 minus sin square A can be written as cos square A. Now let's replace our denominator with cos. We'll get 2 by cos square A. And here we have inverse of cos. Inverse of cos is nothing but secant square. This is our required RHS value. Next, question number 19 we have. Here also we need to take the LCM of the first two terms in the numerator. So LCM will be cos A into 1 plus sin A. That means here we have to do cross multiplication. We'll get 1 plus sin A whole square plus cos into cos is cos square A by the denominator is cos A into 1 plus sin A. Now expand this numerator in the form of A plus B whole square. We'll get it as A square plus B square plus 2AB, that is 2 times of sin plus cos square A, and the denominator remains same for now, cos A into 1 plus sin A. And we have our identity, which is sin square plus cos square is equals to 1. Let's write those two terms in one place. We'll get 1 plus sin square A plus cos square A plus 2 sin A by cos A into 1 plus sin square A. Now here we can replace these two values with 1. We'll get 1 plus 2 sin A by cos A into 1 plus sin A. Now here 1 plus 1 is 2, 2 plus 2 sin A by cos into 1 plus sin. From numerator we can take out 2 as a common factor. We'll get 2 times of 1 plus sin A by cos A into 1 plus sin A. So here we have same terms in numerator and denominator. Let's simplify that. So we are remaining with 2 by cos A, that is inverse of cos. Inverse of cos is nothing but secant. Next we have our question number 20. So here also we need to take the LCM. Let's do cross multiplication, and from this we can take out our cosecant as common. Let's take it out first. We'll get 1 by cosecant A minus 1 plus 1 by cosecant A plus 1. Now let's go with our LCM. This cosecant A remains same. We'll be having cosecant A plus 1 plus cosecant A minus 1 by, so here we'll be having two terms, which is cosecant A minus 1 and cosecant A plus 1. So plus 1 and minus 1 gets cancelled. We'll be having cosecant A, and cosecant plus cosecant is 2 times, we have 2 times of cosecant A, and in denominator it is in the form of A square minus B square. So we'll write cosecant square A minus 1, and we know this identity cosecant square A minus 1 can also be written as cot square A. Let's replace our denominator with cot square. So we'll get 2 cosecant square A by cot square. Now let's transpose, or let's convert this in the form of sine and cos, and we know this cosecant can be written as inverse of sine square, and this cot can be written as cos by sine. So here sine square and sine square gets cancelled. The remaining values are 2 by cos square A, that is inverse of cos is secant square A. Next, question number 21 we have. Let's convert this in the form of sine and cos factors. We'll get cot can be written as cos by sine, and whereas cosecant can be written as 1 by sine, that is inverse of sine. Next term, tan, we have tan can be written as sine by cos, whereas secant can be written as inverse of cos. Let's take the LCM of these two terms separately, and here the LCM will be sine and here LCM will be cos. Here we'll get it as sin A plus cos A minus 1 by sin A. Right? Next we will be having cos A plus sin A plus 1 by cos A. Now let's take this sin A plus cos A as A and this as B. If you observe, it is in the form of A minus B into A plus B, which can be written as A square minus B square. Here we can write it as sin A plus cos A whole square minus 1 square by the denominator will be sin A into cos A. Now expand this in the form of A plus B whole square, which is A square plus B square plus 2AB, that is 2 times of sin into cos, minus 1 by sin A into cos A. So we know our identity that sin square plus cos square can be written as 1 plus 2 sin A into cos A minus 1 by sin A into cos A. This plus and minus 1 gets cancelled. The remaining values are 2 sin A cos A by sin A into cos A. So this values we can cancel it. Then our remaining value will be equals to 2. This is our required RHS. Next question number 22 we have. Here it is in the form of A plus B whole square. Let's expand that in the form of A square plus B square plus 2AB. We'll get it as sin square A plus cosecant square A plus 2AB, that is 2 sin A into cosecant A. And this also we have to expand that in the form of A plus B. We'll get cos square A plus secant square A plus 2 cos A into secant A. So as we know, the sin square plus cos square is an identity. Let's write those two terms in one place. We'll get sin square A plus cos square A. Next, leave the remaining this cosecant as secant as it is for now. Cosecant A remains same, and we know this cosecant is inverse of sine. Let's write that cosecant as inverse of sine, that is 1 by sine A. And we already wrote this cos square here. Let's leave the secant square as it is. And we know this secant is inverse of cos. Cos and cos, sine and sine gets cancelled, and we know our identity sin square plus cos square is equals to 1. Right? 1 plus, here we have 2, plus here we have one more 2, and we know from our identities, that is cosecant square can be written as 1 plus cos square, and also secant square can be written as 1 plus tan square. Let's replace this cosecant and secant with these two identities. In the place of cosecant, I'll write it as 1 plus cos square A. And in the place of secant, I'll write it as 1 plus tan square A. Now let's add all the values here. 1 plus 2 plus 2, 5, plus 1 and plus 1, 7. 7 plus cos square A plus tan square A, which is our required RHS value.